Good morning and welcome back again. Today we are going to finish the last test that we have. When I say the last test, I mean by alternative series test was the last things that we are going to take it from here, because later all things is done. Just we are going to use it again. So after 10.6, we are going to use them in power series. So from 10.2 till 10.6, we got many tests. Technique, you can say technique. For example, we start with the geometry series, and we start with the entity telescoping, then later we P series, then after that one limit comparison test, and after that one we got what? Absolute. And what else? Ratio, root test. We have many. So all these are together, we complete the test with 10.6. So 10.6, we have one test actually, but one and another definition like absolute value. So now here we are in 10.6. We talk about we're going to talk about alternative series test. We say alt test as a brief to memorize it, to remember it. What do you mean by alternative? So at the beginning, be sure that we have okay. Be sure that we have what? We have -1 n plus 1 something here. Why? Plus something, plus un. Why? Because we say alternate. Alternate means that the sign start from positive, negative, like that. So if n start from 1 to infinity, we will get, for example, u1 minus u2 plus u3 minus u4 and go on. Here, we don't depend on this plus. Sorry. We don't depend on the negative sign or positive sign. Our focus will be on un, on the terms of u. We don't say anything about the sign. Understood? So that one is just for recognizing this series is alternative series test, or to tell you to use alternate series test. Okay, good. To give you the clue or more information, look at here. Look at these examples. You can see positive, negative, positive, negative. So it's going to be alternative. I say this is alternative series. I'm not using the test now, just to recognize this one. Also, again, I have minus, plus, minus. So I say that one is alternative series. That one is alternative series. Okay, so alternated. So which? And that one is called alternative harmonic series. Why? Because that one is harmonic, which is diverge. If it's alone, harmonic is diverge. But here, with alternative harmonic series, will be converge. So careful, There it was diverge. That series is diverge. But with minus, will be converge. So that one's called harmonic series. And that one is called what? That one is called alternative harmonic series. So these are like I give you a clue or general information. Later we are going to the detail one by one, example by example, and you know why that one is converged, why that one is diverged, and what's going on. So Look at here. It's not working, I don't know why. This is very important for you. It's Alt. So the test that used for the alternative series. And here we are. We have three conditions, UN all positive and non-increasing and UN approach to zero. You have three conditions. Later, I'm going to apply it over any example that you have, okay? Just remember that you have three conditions. The first, UN are all positive. The second, non-increasing means that decreasing. And that one, UN should be go to zero. Then we can use alternative series test, okay? As you know, as usual, proof is not include. Now I'm going to use to solve alternative harmonic series, convergent, divergent way. So the theorem, all tests say that if you have something like that, your focus will be on what? On UN. First of all, you say UN all positive. Means that here you don't have negative, negative. Two terms negative, okay? If I have positive, negative, or negative, it's okay. But if I have something like that, is not acceptable. If I have something like that, is not acceptable. So the sign should be alternated. Okay, must be alternated from minus negative positive or positive to negative. You got it? So when we say UN all positive, don't say that one is negative. We mean by every time the sign changes, one by one, term by term. It's the first. The second, UN in your book say non-increasing, means that decreasing. What do you mean by decreasing? Means that U1 greater than U2, right? Decrease like that. U3, U4, and go on. So the first term is the biggest term, the largest term. Besides counting the minus, we say that we don't care about the sign here. So should be decrease. The third one, he said that the limit of UN should be equal to zero. Then I can say what the result. If my series, alternative series, apply or satisfy all these three conditions, I say that one is converge. Now, it's time to apply, right? Instead of theoretical things that we apply on the example. I have that example. When I expand it from n from 1 to infinity, I'll get 1 minus 1 over 2, 1 over 3, minus 1 over 4. Am I right? So look at here, alternated or not? Yes, good. So alternated. So I say by alt test, by alt test, I'm going to compare first 1 over 2, 1 over 3, 1 over 4 are all positive or not? Huh? I'm not going to talk about that one. I told you, this is the term. So all are positive. So all positive. The first one, good. How about the second? You say should be decrease. Just check, that one is right. How about that one? And so on. So also decrease it from 1 to close to 0. Okay. Number 3, limit of UN. Where's UN here? That one is UN. Okay. Forget about negative minus 1. Then the other is what? UN. So now UN equal to what? 1 over infinity is equal to, so all satisfied. So I can say, but that series is converge. It's not hard, I think. It's easy. Understood? We solved that example. I remember that in the previous lecture. By what? By absolute, right? If I solve by absolute, you see if we took an absolute value, it remains 1 over n squared. It's converge because P equal to 2. Am I right? Good. And greater than 1. Good. Now, I'm going to solve that one by another way. I told you during the exam, you have the opportunity to solve some examples by 2 or 3 methods. Up to you. And don't ask. Whatever you see is easy for you, use it. I don't care. The important things, your steps and logic steps is correct. Yeah, are correct. So let me solve this one by alternative. By alt. First of all, let me expand. I'll get what? 1 to 9. Okay. First, 1 over 4, 1 over 9, 1 over 16. All positive, yeah. Because we don't have a duplicate, right? We have alternate, so all positive. Okay, second, it's true. Do you think 1 over 9 is less than 1 over 4? Of course. And go on. So decrease. Number 3. Where's UN? Show me. Good. Equal to 0, 100%. So by is converge. So we showed this example in the previous lecture by absolute value test, absolute test, and now by alt test. Understood? But the first example couldn't be used by what? Absolute, right? Because you got a harmonic series, and harmonic series diverge. And you see absolute test is not working for divergence, just for convergence. So I told you in that case, you are going to use something else. That's the something else. That's another way. You got it, Jamaat? So once you should alternate, it's good. We saw that one in 10.2. Look, we saw that example. Look at you. Am I right? You saw many things like that. We see is equal to what? 1 minus 1 over 2, 1 over 4. Am I right? And you see that one is what? Hello? Right? Okay. Who say that geometry? Okay, R equal to? Minus 1 over 2. I told you, when you saw minus, say minus 1 over 2. We say that in 10.2, right? So is our geometric series R equal to minus 1 over 2 is converge. Am I right? Now I'm going to solve that one by alternate. Why? Because I have alternate. So look, we have minus n over 2n, 1 minus 1 over 2, 1 over 8, you can see that, minus 1 over 16, and go on. So I say, first of all, 1, 1 over 2, 1 over 8, 1 over 16, positive. Second, 1 greater than 1 over 200%. I'm sure that decrease. Third, limit of n approach to infinity. Where's un? Where's un? 1 over 2 to power n, you are right. Equal to what? To 2 power n? No, infinite. 1 over infinity 0, you're right. So is converge by, you can solve some examples by 2 methods or 3 methods, up to you. Do you have any question? Even the previous example can be solved by absolute test. 3 methods. That one. We can use the absolute value, absolute test, and we get 1 over 2n, converge, Cartouche, converge. We can use geometric series r equal to minus 1 over 2, converge. We can use alternative test, and use so. Up to you, depends. Understood? Good. So here we are, that's the example. That's the clarification or showing by figures that you can. So this one's the figure of that one is like that and like that. And forget about that. Example number 2. These are all theoretical. We saw that example, right? And this is the sum, you know, when you have a geometric series, you say a over 1 minus r, that's the problem, that one. And now we have a definition, not a test. Maybe in your exercise, you have it, okay? You have it. So the definition is what? Conditionally converge. Conditionally converge. What do you mean by conditionally converge? Look at here. A series converge, but not absolutely converge. It's called conditionally converge. I have two examples. I'll bring 2 examples to get the definition. We have that one. And we have that one. You know, both of them by alt test are converged, right? Hello? Both are converged by what? By alt. Okay. Now, if I take an absolute value, the result will be here is what? How about the result of here? What? That one is called conditionally converge. So the definition say what? If you took absolute value, the result is diverge, say conditionally converge. That's it. Understood? If you took the absolute value, you get converge, don't say anything. Say absolutely converge. But if you took absolute value and you get a diverge, just rename it like conditionally converge. And this is not a test actually. Just this is the example. Why he wrote one p, you know, because if p is 1 or less than 1 is converge. If p is 1, so if p is 2 or greater than 1, it will be diverged. That's why. Look at here and that one. Rearranging, we don't need that one. We talk about that one in the 10.2, just how to play with here. It's okay, we don't need that example. And that's all for today. This is the summary of what? Converge and diverge of your first entity, second geometry, third P series, that one, and the series of negative alternative series tests, ratio and root tests. Comparison test, that one, limit comparison test, ratio and root, you can see all of them. So from 10.2 till 10.6, you got all this one. You got it, Jamaat? Guys? Good. Later, look, later in 10.7, we are going to use after summarizing our work, we go to X. After guessing the X, we say, look, because I'm going to show you something. We are going to use something, then we will get harmonic series. So we are going to use all of them in 10.7, all of them. Okay? Just like a bell mouth. Later we will summarize all of them here. So careful. And again, Some of them is alternative series. Look at here. We are reading to alternative series. Some of them diverge, negative value. We are going to use all things that we got it before. So carefully, try to study 10.2 to 10.6 carefully, one by one, example by example. Any question?